started by looking at a linear function and just looking at, I guess it's kind of a piecewise function, or maybe just look at a little bit of a linear function. And I'm also going to use this to review a little bit from domain and range, because it's going to be helpful for that. So if you follow the link that I have on D2L, it should open up something like this. And what I've done here is I've given you a graph, kind of partially filled in, and a table. Now the nice thing about the way I set this up is that we can plug in points to help plot our graph. So let's take a look back at our function. It's f of x is x minus 7 over 2, and WebAssign might ask you to evaluate the function at these points. So okay, let's do a little bit more than just kind of the minimum that was required for us from WebAssign. Now f of 0, you can probably fill that one in your head. 0 minus 2 or 0 minus 7 is negative 7 divided by 2, negative 7 halves, or negative 3.5. But if you got to do a lot of these, like 5 or 6 of them, it's not a bad idea to get technology involved. So that's what I did for you on this Desmos link. You can type in a 1 and it'll fill in the y coordinates. So 1, and then let's see, I want 2, 3, 4, 5 all the way up to 5. So let me keep going. If you press enter, a 2, a 3, a 4, and a 5. And kind of the cool thing is that it actually puts points on your graph for you so you can see those. Let me copy down these values. So what you can see is that they're increasing by a little bit for each value that I increase in x. In fact, can anyone tell me how much they're increasing by?
0.5.
Yeah, 0.5. And you can see that a different way if you look at this and think of this as, well, you know, f of x equals x minus 7 over 2 is really x over 2 minus 7 over 2, or better yet, 1/2 x minus 7 over 2. So the 1/2 is your slope, and the minus 7 halves is your y-intercept. And you can see that reflected in this value right here. 0 for x gives you negative 7 halves, or negative 3.5. And from there, it's going to increase by 1/2 each time. So negative 3, negative 2.5, negative 2, negative 1.5, and finally negative 1. Now if you plot those points here, it's going to be tracing out a graph. And let me see, I should probably, yeah, it's going to trace out a straight line between these. Let me zoom in a little bit, see if we can't make that a little bit easier to see here. So I've already got 0 and negative 3.5, and then 1 and negative 3. So that would be here, and then negative, or 2 and negative 2.5 here, and so on, like that. You can play connect the dots. So let's do that. And I've gotten everything here. Now, one of the messages that I've gotten from you, and I appreciate the feedback a lot, is that you're still a little bit unsure about domain and range. And this is kind of a nice user-friendly option to look at it with, so let's take advantage of it. Domain was associated with which coordinate? The x coordinate. So let's look at all the x coordinates that are represented here. And that would just be these right here. So as far as your domain would go from 0 to 5. So let's do that. Domain is 0 to 5. All right, so domain is 0 to 5. How about the range? The range was associated with what coordinate? The y coordinate. So let's put the y coordinates in here. And I'm going to do myself a little favor here. Since I'm including the endpoints, I'll do it there as well. So let's do those. And maybe you can race me. What's the range? what numbers would constitute the range? Yeah, negative 3.5 to negative 1. Bottom to top. Please don't give me negative 1 to 3.5. I'll really struggle with should I take off a point or not, because you should be from lowest to highest or left to right. One of those two. So now how about we do that on the graphing calculator? So bust out your graphing calculator. Let me clear up a few things that are here. And clear out this value here. I guess my question to you is, do you want to try and do this a little bit fancy or not? Or we're going to try and be just regular pedestrian. If you're trying to do it with a little pizzazz, a little bit fancy, hit this alpha key, then the y equals key, and then type the number 1. So one more time, that was alpha, y equals, and then the number 1 should give you exactly what I have up there. Now let me clear this out because I don't need two fractions. The nice thing about doing it this way is you don't have to worry about parentheses so much. So it's just x minus 7 divided by 2. If you're not really keen on that, if you just want to do it a regular way, you can always just put parentheses around the numerator and work things like that, divided by 2. One of the settings that I've mentioned before is for your table setup. So try the table setup, make sure that things are set the way they should be. Second window, you want your independent set to ask and your dependent set to auto. Doesn't matter what table start and delta table are, just make sure that the other two are set the way that I have them there. When you have those set, then let's actually go to the table, second, and then table. I'm going to delete those values there. Those are left over from my calc class this morning. And let's just type in the numbers that we want. 0, 1, 2, 3, 4, and 5. So you can see the difference between those two outputs. When I have it set up with that horizontal fraction bar, to the extent that it can, it'll give me an actual fraction, whereas over here, the second way just gives me a decimal. If you want to make this first column into just decimals, if you're like, no, I don't want to look at fractions, you can do that. Let's go back to the y equals. Cursor past your function, then hit the math key. The second option there turns things into a decimal. So math, and then 2 takes your answer, turns it into a decimal. Antonio?
Does it matter if you do fractions or decimals?
Not to me. No, it doesn't matter to me. But I mean, sometimes people are a little uncomfortable, with that, and they just want a nice decimal. So there you go. All right. Nice. How are we looking on that one? Yes, question.
On the exam, do you have a preference over one or the other, whether we give you a decimal answer or a fraction?
I tend to prefer fractions,
Okay.
but if I really care to the point that, I'm going to award credit for one way or the other, I will say so in the instructions in the problem. I'll say, give me a fraction as an answer, give me a decimal as an answer. If I don't say anything, then I guess it's kind of up to you what you want to give me. All right, it's shame on me for not specifying anything. All right, let's look down at this next graph or next set of graphs. This is the graph of y equals x squared plus 10, but I've got several different windows. And I want you to take a minute and try and decide which window you like. Which window you think looks good. And then we'll go through and we'll comment on all of them. Now, all of them are showing you the same function, but, well, I don't know. I'll give you another minute to look at that. Let's figure out what we got going here. this first graph? Is there anything about this one that you're like, well, it's nice, but? Alex?
There's no x-axis?
Yeah, there's no x-axis. So that one can be a little disconcerting sometimes because it's nice to have that x-axis there. It gives you some orientation. It helps you understand the graph a little bit better. So it's a comfort zone. This one. Is there anything wrong with that one?
Large numbers.
You got some large numbers. What else?
The x-axis, in my opinion, is too low. The parabola.
All right, x-axis is too low. Well, we kind of have to have the x-axis here because that's where it is. But there's something else about this that kind of bothers me about this one, and that is it kind of reminds me of the pictures, and no slight to Grandma, she was wonderful, but it reminds me of the picture that Grandma used to take, where like we're all really, really small and like 50 feet away from the camera, and all you see is this little image of us, and you got this great image of the foreground and the background, but not much of us. So it's just kind of small. There's a lot of wasted space in this graph. You just, got a lot of extra room here that you're not using. So we're wasting space. This is too small relative to the size of the graph. Too small. How about this one? What's wrong with some? Too wide? Rachel?
X-axis, like the numbers on the x-axis are too small.
They're too small? Okay.
It kind of looks like a straight line, even though it's not.
Yeah, it almost looks like a straight line. You're zoomed in too much on this one because, yeah, it looks just almost like a straight line, even though like, hey, wait a minute, that's a parabola. That's going to have a kind of a U shape. Not a perfect U shape, but a little bit of a U shape. And you're not seeing that there. It looks almost straight. So you're zoomed in too much. In too much on the x-axis. What do you think of the last one?
I think it works.
Thumbs up on that one. That one's the one that Goldilocks would have chosen, right? This one's too zoomed out. This one's zoomed in too much. This one's just right. So that one's perfect for us. So, yay. Like this one. So that's, the kind of graphs that I want you to be able to come up with. It's a typical problem on an exam where I just give you a simple little equation and say, find a good viewing window. And what I'm looking for is I don't want you zoomed in too much. I don't want you zoomed out too much. I want to see the x-axis and the y-axis. So those are the things that I'd be looking for a problem like this. So let's try that again for a different problem. This time I want you to try it. So this time our problem is right here. F of x is 8x minus x squared. I want you to experiment and try and find a good window. So let's take a look. First of all, we've got to change our function in our graphing calculator. So hit the y equals key, clear out the stuff that's there. I just like clearing out everything. And let's type in 8x minus x squared. And then it gives you several different viewing windows. Now let me clue you in as to what they mean by some of these things. What they're giving you there is your x-min and your x-max and your y-min and y-max. So that's the format. Not x-max, how about x-min? X-min, x-max, by y-min, comma y-max. So they're giving you the window settings that you should look at when you go through all these. And then what you should do is put in these various window settings and see what you think. Which graph looks the best? So if you're watching this at home sometime in the future, then I'm going to pause this, walk around and help out people. And you can try this yourself. See if you can answer, comment on the sheet here, what you like about some of these graphs, what you don't like about some of the other ones. See if you can't pick a good viewing window. If you finish, confer with neighbors. See if you agree with your neighbor. Michael, do you need to borrow a calculator?
Yes,
Come on up. Keys or a phone?
so much for a subtle entrance.
Yeah.
Thank you.
Keys or a phone?
These are a phone? Yeah, which are on my desk. Here. It's really fancy.
Good enough. Plan on tripping someplace?
Harder to lose than your regular
Put it in
driver's
like
license.
5 and negative 5, which changed it to like 55.
Let's see, so
No.
you want -5 to 5. And then -5 to 5 again.
No.
Just hit the delete key when you press that extra 5. There you go. Did you put it in the function? Yeah. Okay. Okay, good.
I understand this part. I guess I don't need to put decimal here.
Not this one. I mean, it won't hurt for that one.
Yeah, but how would I go about doing this?
So what you want to do is you want to set up the window to match this. So it's
Oh,
-5 to 5 on the x-axis,
okay, so you click window.
and then same thing on the y-axis. Okay?
Okay, and then graph it?
Yeah, and hit the graph key. You should get a graph. Well, it won't be a good graph. All right, so let me just make one thing clear here. So when they're giving you these settings, that's for your Windows settings. So after I've typed in the function, then I want to go to the window and do, say, for instance, for the first one, -5 to 5 on the x-axis and -5 to 5 on the y-axis. And then when you hit the graph key, you should get something like that. Now, if you're happy with that graph, great. Maybe that's the one you want. If you're not, then keep going. Well, either way, keep going. Try and find which one of these looks the best.
Does the X scale and the Y scale matter?
It will. And I'll talk about that in a little bit. But okay, so what that does, the X scale and the Y scale will tell you where the tick marks are. So, for instance, if you look at your graph, you don't have any tick marks. Let's put it at 1. And what I'll get is tick marks every 1 unit here. If that's too many, sometimes you get too many, like, I don't want all the tick marks. Then what you can do is, let's choose 2. Maybe that's a little bit less busy. You just got to realize that that's a 2, 4, 6, 8, 10, double 10, as opposed to 1, 2, 3, 4, 5. And you do the same thing on the y-axis.
Thank you.
Yeah, that should be able to correct. We mentioned. Okay, let me check back here. It's good. Hit the clock turned on. Shut that off. Now hit the graph key. It should work.
Yeah, for this class, which is really annoying because on Penn State tutoring out, it said that they need her from 11 to 8 or something.
X scale. Yeah, I'll talk about X scale.
And then when I did a graph,
Yeah.
not a straight line.
So it's not really probably our optimal graph, right?
Yeah, I was gonna say a lot of these don't seem like
So I made
a
a
lot
bunch
of
of
numbers over a straight
Right.
line, so.
I don't know if you can tutor
You just keep putting in your point.
That's
All right.
if you go into the AC, they have a bunch of these out.
Okay, so a couple things, it helps me out to walk around and work with you guys. A couple common errors that I see when people try and do this. One of them, a lot of times you'll see something about dimensions when you try and do these types of problems. And the reason for that, let me just put in a couple numbers here. The reason for that is because you'll have something turned on that you shouldn't have. If you hit the y equals key, well, I guess I got to quit here first. But if you hit the y equals key after you get that error and see that your plot is turned on, that could cause an error. So you just go up here with your cursor, press enter to toggle that off, and now your graph should be okay. I've got my window settings okay. I hit the graph key and I get something like that. Doesn't even look like a parabola, does it? How do I know to expect a parabola? What about this says I should include a parabola? Yes?
It's because we have an x squared.
Yeah, you have an x squared. You expected a parabola. This looks like a graph of a straight line, I guess. So this is zoomed in too much on the x direction. We can't see enough of it that it doesn't look like a parabola. So zoomed in too much on the x-axis. All right, so that's not optimal. What else can go wrong here? A couple of you, when you're entering in these numbers, put in a subtraction key for the -5. It's going to give you an error when you do that. At least it should give me an error. Not sure why it didn't. Oh, it changed it for me. But you have to use the opposite key down here, not the subtraction key. Let's try the next one down. So that was -10 to 10 and -10 to 10. Now I'll give you a quick heads up here. There's a shortcut to get to those settings. If you just want to go from -10 to 10 and -10 to 10 on the x and y axis, the fast way to do that is zoom standard. So zoom 6 is going to give you those settings. So it's not a trick that I require you to know. It's just kind of cool. Holly?
What about the zoom fit?
I'm not talking about zoom fit right now. Yeah, zoom fit can help out sometimes, but it's not going to do what we want it to do here. So this one's not bad. It's better. But what would you say is wrong with this one as far as a graph is concerned?
See the absolute maximum.
Yeah, you're not seeing the top of it, right? This is a parabola. You don't see the vertex. So yeah, that's a little bit annoying. So can't see the vertex. See the vertex. Let's tweak that one a little bit. And a couple of you asked me about, well, what's that XCL stuff and Y scale stuff? So let's take care of that on this one. On the x-axis, I want to go from -2 to 10. On the y-axis, I want to go from -5 to 20. And that's a long distance on the y-axis. I'm going up a total of 25 units. This scale here tells you how often I'm going to get a tick mark. And right now I'm getting a tick mark every unit. And it's starting to get a little bit busy there on the x-axis, right? I mean, I'd hate to have to count and figure out, well, gee, where's this at? And then have to get stuck counting all the way up here. So what could you do about that to help out? Well, that's where you're going to use the scale. Let's try something a little bit bigger, like y scale equal to 5. Now when I hit that graph, oh, these are a little bit more spaced out. It's a little bit easier to read. and you go 5, 10, 15, it looks like it maxes out at 15. So what do you think about that graph? How's that one looking? Yeah, that one's a good one. I like that one. So let's just put a little smiley face on that one and look at the last one. The last one I want to go negative 10 by 10 and negative 100 by 100. Okay, so window, negative 10 and negative 100 by 100. Now here's where you really would want to change your y scale. Suppose I just left that at y scale equal 1. Take a look at what a mess it's going to make on my y-axis. It's just kind of like a solid line because it's trying to draw too many points. So let's go back and change that to something a little bit more helpful. What would be a different value of y scale that I could put in there? 10? 25? Yeah, 10 and 25, come to mind, 20 would work. So one of those that goes into 100 evenly. So I'll just choose 25. And there you go. Looks pretty good. It's not perfect though. Is this one your favorite? No, not my favorite either. What do you see wrong with it?
Cuts it off midway, so it's off-putting.
Yeah, you don't get a symmetric view of your parabola. That's part of it. I mean, you see part of the right leg of the parabola. Is there anything else? Genevieve? Anything else you'd criticize about this one if you tried to be picky about this? Suppose you had a bad day and you're grading some student's paper, you're like, oh, I got to find something wrong. What would you find wrong with this one? Not that it's ever me, even when my favorite sports team lose.
Well, the scales are too big, like I'd have trouble putting in the points.
Scale? So you want a different scale there? Okay. Pfeiffer?
It's like a little squished.
Yeah, it's a little squished. I mean, take a look. The top half of this graph is just blank, right? It's just wasted space. So if I was going to try and clean this up a little bit, I'd probably do two things. First of all, I think I'd maybe go over to -7 as opposed to -10. And then on the other side, I should probably go a little farther, maybe, up to 14 or something like that. So I'll change that. And then I'd also change things on the y-axis. I don't need all this stuff up above because it's wasted space. So let's reset this and try -7 to, I don't know, let's try 14. And on the y scale, y max, well, let's go up to maybe 20. And I'll change this to 10. So I'm making a lot of changes here in my graph. I'm changing the y max so that I don't waste too much space above. And I'm changing y scale so that the tick marks are a little bit more informative. How's that one looking?
That looks better.
Yeah, it's a lot better. Okay, so this is a type of problem that I will ask you on an exam. Give you a function and say, come up with a good viewing window. Now, does it have to match mine exactly? No. Bonus points if it does, but it doesn't have to match mine
Are
exactly.
you going to give us multiple choice or are you going to expect us?
Nah, I think I'm going to let you freeform this one. So just give you a problem and say, find a good viewing window. All right? So, other questions? No? Doing good there?
I guess how did you just come up with the numbers?
So, for instance, when I was coming up with that -7, I was looking at the graph, and to the left of -7, the graph had gone below the viewing window. So I'm like, all right, well, anything past -7 was a waste. And then in terms of the y max, I realized that, all right, a lot of that graph above was just wasted space, so I just lowered the value of y max. Now I happened to choose 20. You could have chosen 17 or 23. It worked the same. It's, again, I'm not looking for something that identically matches mine. There's going to be a lot of wiggle room. So what I'd be looking for is something that mostly gives you a nice symmetric figure here, and that uses most of the available space. You know, it doesn't have to be perfect though. Yes?
Something else that would help is that I found the points for the graph, so I chose 0, 1, 2, 3, 4, 5.
Okay.
All the points, and then I just like modeled what matched perfectly with my points.
Yeah, so
It'll make it easier if you don't have some numbers. You can
that can sometimes help, especially like in this first example where I knew that I was just going to be looking at things between 0 and 5, and then you can say, all right, well, if I'm just going between 0 and 5, I'll need these numbers. And that's from your that's from your screen here. The difficulties you're going to run into is that you might not know all the correct values of x to plug in in order to advise you as to what window you're going to take. Because if you have a different function, it could mess with things. So appreciate the input there. This one is waste space on top, and a bit to the left. So the other day we practiced calculating or working with piecewise functions. We're going to do that again with some of these so that you can feel comfortable and confident when you approach the exam. So let's look at this first one here. F of x is 0 for x less than or equal to or less than 5, and 1 for x greater than or equal to 5. Okay, so we're going to graph this first of all on our graphing calculators. So let's do that one. Let me clear out this, and let's go up to the y equals key. Now this function is pretty simple. It's just y equals 0. But I only want that if x is less than 5. You remember our little trick the other day to graph this for just those values? So I had you hit a divide by key, and then we put in the condition. That is, x was less than 5. So parenthesis here, x, and bonus points here. Who's got it? Where do you find the less than or equal to, all those keys? Second math. Second math. And this time we want x less than 5. So I ended up typing 5 twice there. And that's for the first part of the function. Now there is a way to do this all on one line, but I don't do it that way. I just try and keep it simple. The second part is x equal 1. And again, that's for this condition. 1 divided by parenthesis x, and then your second math key again. This time x has to be greater than or equal to 5, so this is going to be the fourth option down. And then if that's true, this is called, or that's going to give you a 1. So that's going to be our graph. We're going to pause here. Excuse me, it should be a 5. My bad, thank you. I'm going to pause here for a second. Has everyone got this typed in correctly? We're all good on this? All right. Let's set up our window, because our window's set up from our previous problem. So what's that going to look like? Well, we have window. I don't know as though I need to really go down to -14. Maybe I'll go to -2 just to get something a little bit to the left of the x-axis. Maximum, well, I don't know, probably want to get a little bit above 5. So let me go up to maybe 9. On the y-axis, well, I'm really only going to be graphing things that are going to be a 1 or a 0. So I don't need to go down very far. If you let y equal 0, the x-axis will be on the very bottom of your calculator. So sometimes I like to see that x-axis. So I'll go negative 0.5 up to 1.5. I like having a little room above and a little room below my graph just so I can see it and make sure it's not tailing off and doing something strange. Y scale, I'll set that equal to 1. And when you're ready, hit the graph key. And you should get something like what we have here. So the graph is just this line that's on the x-axis up till x equals 5. And then at x equals 5, then it jumps up here. If I remember right, this is sometimes called the heavy-sided step function, but it's not something we need to know here. Were you able to get that graph? Looking okay there? You can do the same thing in Desmos if you don't have the graphing calculator at home. You can do the same thing in Desmos. It just looks a little bit different. Actually, works a little bit nicer, I guess. Let's see. So f of x equals 1, and then the notation, actually let's start with 0. The notation looks like this. X is less than 5. I need to put that in parentheses, brackets. X is less than 5. And then repeat that for f of x equal, I don't want to use f of x. I'll just do y equals 1 for x greater than, and if you type the equal to key next, it'll just put that equals right under there where it belongs. Greater than equal to 5, and there you go. Hit the tool key, make it a little bit brighter, zoom in, whatever you like, but you're getting the same graph. So you can do it either place, depending on your needs. So you get a nice graph. And let's draw it here, and then move on to some of the next ones. So, like that. So this part of it is going to be along the x-axis. And then I'm going to have another part a little bit higher up. Let's see. And then this part is going to be right here. Which one of these gets the solid dot? Which one of them gets a hollow dot? The orange graph or the red, or orange graph or the blue graph is going to get a solid dot at this end. Well, this is for x less than 5, right? Does that include the 5?
No.
No. So is that going to get a hollow dot or a solid dot? Hollow dot. And then up here, since I am including the 5, I'm going to have a solid dot there. So there's my graph. Nice. Nice. All right. Let's try the next one. Next one, let's do this one on our graphing calculator. So here we're going to have to be a little bit careful plugging this stuff in like we were just a moment ago. So we're going to plug both of these in one at a time, and then we can set up our window. So I'm going to clear that out, clear these out. And again, if you need to follow me, my key history is down here. I'm going to start by plugging in 2x plus 6 into my calculator, except I want to put that in parentheses because I'm going to need to divide by this condition also in parentheses. So everything needs to be in parentheses. Left parenthesis, 2x plus 6 divided by left parenthesis again. This time x is less than 1. X is less than 1. No, thank you, negative 1. Thank you. And likewise down here, 6 minus x is greater than or equal to negative 1. or when x is greater than or equal to -1. So 6 minus x, right parenthesis, divided by left parenthesis, x greater than or equal to -1. So here's your test, greater than or equal to -1. Now I'm going to give you a minute to figure out, well, where do you want to set up the window? How are you going to graph that? And if you're totally lost, then maybe look around at something. There's kind of a clue here. It's a big clue as to where you should set your window. Yeah, standard window could work pretty good. All right, but there's actually a clue. I mean, standard window is a great place to start. If you have no idea of where to start, your standard window from -10 to 10, -10 to 10 is a great place to start. And then you can kind of move around as needed to figure out where to fill in dots. But there's another nice clue as to where to graph this.
Would it be to solve each of these?
There's nothing there to solve, but I appreciate the suggestion. Yeah, maybe look at the graph that I have here and say, oh, well, maybe -10 to 10 on the x-axis and, I don't know, maybe -8 to 10 on the y-axis. Yeah, you don't have to always reinvent the wheel. If you're given a graph on the test or in WebAssign, just use that, right? You know, that's a great place to start. So had you done, say, Zoom 0, or not Zoom 0, Zoom 6, Zoom 6 is Zoom standard, that's not too bad. Although I think I changed it when I actually did our graph, and I think it went down to like -8. So let me just change that real quick. Let's go down to -8 for y-min. And maybe I'll put y scale as 2 just for variety there. So these tick marks on the x-axis represent units of 1. On the y-axis, it represents units of 2. Question for you. Which one of these is going to get a solid dot? The red graph or the blue graph? Michael?
Red graph.
Yeah, the red graph. All right, because we want x is greater than or equal to -1, and that's going to happen right here. So let's put those, let's come up with some notation for that, or at least color coordinate that a little bit. I'm running out of colors here. Well, not really. Let me just do it this way. So, oh, that one's dying. Let's try this one. There we go. So that one's going to be here. X is less than -1. So that's that graph. And then we have another one. I think this one works pretty good. So this one's going to get the solid dot like that. So there you go. All right. Looks good on that one. Let's try a couple more. So we're going to sketch this graph over here, and this one goes up here. So let's start with this one. This one, the top part and the bottom part are okay, but this one in between requires a little bit of extra care. We did something like this the other day. You've got to, if you're doing this on your graphing calculator, you've got to put that in kind of 2 pieces. Do you remember when we did that? We had to break it up. It was parenthesis, -2 is less than or equal to x, and x was less than or equal to 2. That's the condition you need to divide by, and you need those double parentheses in there. So why don't you see if you can't fill that in, and then graph it. Graph it over here. No, just this. Well, yeah, all 3 of them, all 3 parts. And I think I've got a typo somewhere. Yeah, I do have a typo, but maybe you'll fill it in. Maybe it's not even a typo. I don't know. I'll let you work on it. So. Fill in these, graph it, and then see what you can do in terms of figuring out the window for this one. Help each other out. I'll walk around and try and help out as well. Oh, nice. Well done. Wait. That's just a condition for the middle one. So, what you would need to put ahead of that is the function. So, second answer, x squared divided. So you want to always divide by the function. Okay? And then always divide. But then you got to put in this one, and this one. You got to put in the other parts of the function. Adjust your window as well. And it looks like there's something wrong with it. It should be more of a continuous function. Double check what you input. Looks good. Think about your window. That's not a window. Function there that needs to be x squared, and you need to divide by that function. That's what this is. Oh, you need parentheses around the negative x plus 6. Or you could write it as 6 minus x. Either way, let's do this. If you hit the second key, then the insert key, then you can plug in something like, yeah, that. I don't know if you can, go ahead and hit the second. Second, insert, and right parentheses. Now it should give you what you're looking for. You might want to tweak your window a little bit, but I mean, it'll graph right now.
Yeah.
And so maybe make Y max a little bit lower. Okay. Let's see here. That should be a -2. So let's make that -2. See about graph? No, it's disconcerting that this is all at the top. So sometimes I want to make that a little bit higher. Let's go to y max and maybe make it 5. That way you can see that there's nothing else going on. You know what I mean?
But I have a question, isn't it that these two don't come?
Yeah, that actually. Did you need something? Yeah, nice. They're very nice. Very nice. Oh man, look at that trash talking over there. All right. So let's look at this. Let's see. So I want to replace this with. All right, folks. If I can get back and finish this off, I think this is the last example we're going to do, and then we'll take a break. So 4 divided by parentheses. Shukran. X. Let's see. Second there. X less than -2. And then next part of the function was x squared divided by, and I wanted 2 conditions here. The first one was x was, or -2 was less than or equal to x. Oops, I need an x here, and then that. And the other part was that x was less than or equal to 2. Second math. So less than or equal to 2. That's the second of my conditions. Right parenthesis to close off that condition. Another right parenthesis to close off the denominator. And finally, the last part of this was -x plus 6. That whole thing has to go in parentheses. Divided by parentheses, x is greater than 2. X second test greater than, that'd be number 3 there. 2. Yes?
So would it be incorrect if we put the x squared in parentheses?
No, wouldn't hurt. The reason I have to put it in parentheses down here is because I want both of these things to be divided by that. I want the whole condition, not just the 6. So if it's more than one term, that's where you need the parentheses in the numerator. So like the first 2, I didn't need it. The second one, or the third one, I did. Now, as far as the window is concerned, did anyone use the trick that I suggested last time? You just take a look at this window and kind of match it. So I'll go a little bit higher than I need, which is 5, and a little bit lower than I need, which is -1. So -1 to 5 in the y direction, and then -4 to 6 in the x direction. Should be good. So let's set that up for our window. Let me clear this out. Window, -4 to 6. You know, there's a lot of tick marks there, so I'm going to make x scale equal to 2, and then -1 to 5 in the y direction. And I'll just make y scale equal to 1 there. Looks pretty good. Now, it didn't quite close up here, right at the point -1, 4. That's okay. We'll figure that out for ourselves. So let's draw this. Let's see. We'll start out with this in orange. The graph of y equals 4 is just a horizontal line up to but not including that point. Is that correct? Why do I have a hollow dot here? It's less than -2. But that hollow dot gets filled in, doesn't it? Does anyone know why that hollow dot gets filled in? This part, right here. Yeah, it's x is less than or equal to, or I mean -2 is less than or equal to x less than or equal to 2. So for the parabola part, you actually fill that in. Because the less than or equal to at -2, -2 for x would give you 4 for y. So it fills in that hole. And then the last part is -x plus 6. And that's for x greater than 2. Well, that's going to start out here and kind of go down. And let's see, I think it's going to go through the point at x equal 4 and 0. Is it 4 and 0? Let's see, trace 4? No.
Under the table we did error.
Let's take a look here. X is greater than 2. Why am I not figuring that? Oh, it should be 6. 6. That's where the graph's going to cross the x-axis. When x is 6, -6 plus 6 is 0, so that's going to cross the x-axis down here. So let's just draw ourselves a nice little straight line. Now this part of the graph actually has a hole here, but that hole is filled in by your parabola. So the rest of this looks like this right here. Okay, so it's a hole from this part of the graph, but this one fills it in. This hole is filled in again with the parabola, and then you have a hole for the part where x is less than -2. Overall, here's your graph. How's that one looking? Doing okay? Are you okay with finding these piecewise graphs? All right, nice. Let's put this one to rest.